Hi guys, and welcome to this video on our log transform. I'm Maffs Guru, otherwise known as Darren. Actually, that's how I'm known. I suppose it would be otherwise known. Anyway, that whole new discussion. Thank you very much for joining. This is the third video in our data transforms for the Further Maths course. Thanks for coming along. If you haven't already done so, do me the honor, please, of subscribing by clicking that little doohickey in the corner. Your support is greatly appreciated. Leave a message below if you can do, and tell your friends about this channel. I've got about 1,200 subscribers, which is awesome. I think most of those are my family. Everyone else is out there watching cat videos. Now, the log transform. In our previous video, we have looked at the x squared transform, which is also equally supported by the y squared transform. We're going to look at log transforms now and probably deal with one example, but it applies to both a log x and a log y transform. Now, in previous lessons, we have looked at this wonderful circle of transformations provided by Cambridge Essentials textbook, the Cambridge Further Maths textbook. And so we can see that data curves in one of four ways, and we're trying to turn that linear. So we have a log x, a log y, and a log x. That's interesting, and a log y. So again, there are three different sort of formats of graph where we can do log transforms. What does a log transform do? Well, if you go back to a previous video, then we knew that, for example, the log base 10 of 1,000 came out to be 3. The log base 10 of 100 was 2. The log base 10 of 10 was equal to 1. And so if you remember from that previous lesson, as these numbers got progressively larger and larger and larger, we sort of were able to scale them back and make them smaller, sort of redefine the scale as it was. Hold on a moment, that's what we're doing here. I know, I get way too excited about this stuff. Sorry guys. So let's have a look at some sort of practice data and see why this is happening. So there we go, we've got a nice curve there, which we know from our circle of transformations a moment ago is ideal to transform using a log x transform. Now at this moment in time, there is my x value and there's my y value. And if you've watched our previous video or my previous video, then you know that we've got to be also very careful what these be changed to. So we are saying, well, a log turns big values into small values. And what that would suggest in this situation is, that's right, points at the far end are going to move in and in and in. So what we would suggest was this point here, which is really, really wide away, will probably move all the way back here. Now, although that doesn't look necessarily straight, you've got to remember my y values are not the ones that are changing. This value here may move to here, and here, and here, and here, and here, and here. And what do we notice? I know I've constrained it that way, that actually these will come into a nice straight line. I've effectively just squidged them in. And yes, what we would need to make sure in that situation is that this now became y, and this here would become log of x. That would then give me a nice sort of linear line. Now again, remember from previous videos, we are given a number of transforms. If we go back to this circle of transforms here, we are given a number of transforms that could linearize the data, and we are looking to choose the one that will give the best linear approximation. Now, how do you know that? Sadly guys, you try all three, or if you are over here in Australia, you are probably advised to try all six. How do you do that? Well, ultimately, once you've got the data in your calculator, you're just adding extra columns. This will come in a later video because I'm going to go through maybe a practice sack. But the point of it is you are looking for the best linear. And in this situation, a log x may well turn out to be linear. Now, again, as I've said in the previous lesson, and I'm going to keep going over and over this, if you remember, the equation of a straight line, which is what we're trying to do, turns this into y equals mx plus c format. That is the stuff we've taught you in year 9 and year 10, but obviously for further maths now, that becomes y equals a plus bx, where the value of a is our intercept and the value of b is our gradient. We know this. Now don't press stop, not just yet guys, this is a preview video and you've reached almost the end of it, but it does continue over on mathsguru.com. Mathsguru.com, yep, that's my custom website, bits of it you can see around me at the moment. That has been designed to allow the videos to be easier searched than they are on YouTube. So you can search by chapter, by textbook. Each video has downloadable notes for you, so you can put them in your summary book or your exercise book. There are exam questions, and there is more and more content and more stuff coming. as time allows. So head on over there. It's absolutely free to sign up, and I'm doing everything I can to make sure that you guys enjoy maths and actually take out the mystery of maths. It is not as hard as you think. It is all smoke and mirrors. Okay, thanks very much. Take care, guys. I look forward to seeing you in another video. Stay safe.